We're going to now move into our next unit. The previous unit, we worked with slope. We found the y-intercept. We used the formula for slope. We used the graph for slope, rise over run. And so now we're going to move into the next fundamental concept of algebra, which kind of is the basics of algebra, which deals with equations. We have two different things that we're going to work on. First thing we're going to work on are expressions, and then we're going to work on equations. Now, just like the other videos I think you've done, as you go through these notes, through the video, pause the video to take your notes. If at any time during the video you have a question, raise your hand, all right? So the first thing I want you to understand is that when you have an expression is basically just a simple little statement, right? If I have 5x plus 3x, 5x plus 3x plus 10, that is an expression. Whereas if I have 5x plus 3x plus 10 equals 30, that is an equation. What is the difference between the two? You'll notice with an expression, it's just a series of terms, whereas the equation has an equal sign. So that is the main difference between an expression and an equation. One of the things I also need you to remember, I'm sure you talked about, is we have something that are called terms. Terms are things that are separated by addition and subtraction signs, okay? So what I'm going to do is I'm going to go on to the next page, and I'm going to have a list of terms for you to copy down. So some of these things are things that you know. Some of these things may be something new for you. So for the first thing we have are terms. Terms are separated by addition and subtraction signs. So for example, if I have 5x plus 2y plus 3. My board's kind of messing up, so let me restart my board real quick. So if you'll give me just a minute. All right, so let's try this again. We have 5x plus 2y plus 3. All right, what you'll notice, let me go ahead and put a minus 2r. Let me also put that. You'll notice I have 5x plus 2y plus 3 minus 2r. Terms are separated by addition and subtraction signs. So here's my addition sign right here. So I'm going to just kind of do that. I have an addition sign here, and I have a subtraction sign there. So my terms for this expression are 5x, 2y, the 3, and that 2r. Actually, it will be a negative 2r because of that minus sign. But main thing is just for you to notice what the terms are and how many are there. So if I look at here, I have 1, 2, 3, 4. This is a term, that's a term, that's a term, that's a term. So in this problem or this expression, we have 4 terms. So again, terms are separated by addition and subtraction signs. All right, the next thing, we have coefficients. Coefficients are the numbers that come in front of the variable. So if I have 2x, the 2 is my coefficient. If I have 15xy, my coefficient is 15. If I have just plain y, my coefficient is understood to be 1. Remember, if a term does not have a coefficient, a variable does not have a coefficient, it is understood to be 1. Next thing, we all know variable. A variable mess up again, so turn it back off and turn it back on. So a variable is a symbol that represents an unknown value, a symbol that represents an unknown value. And our examples that we're going to have are letters. So a letter is our variable. All right? So what I need you to do is copy this down if you don't. If you need to, pause the video. So yes, I do want you to copy this information down. You've got a good bit of work or notes that you're going to have to copy today. So when it's all said and done, you're probably going to have between 2 to 4 pages of notes, depending on how big you write. So like I've said before, pause the video and start it as much as needed and ask me questions as we go along. All right, our central question: how can I use the distributive property to expand an algebraic expression? And we're going to be working on, to start with, expanding algebraic expressions, and this goes with 10-1 under the accelerated, not grade 8. So this is under the accelerated. So just to emphasize, this is under 10-1 accelerated. So when you get to your digits assignment, go to accelerated. All right, expanding algebraic expressions. So as we work through this, I'm going to need you to copy stuff down. So our central question, you should have it down. How do I use the distributive property to expand an algebraic expression? So once again, if you'll make sure you have this down. All of you have heard of the distributive property. So the distributive property, as we're going to apply it, is basically we're saying the algebraic expression in this example, 3 times x plus 2 in parentheses, is a product with 2 factors. Our 2 factors are the 3. Factors, as you recall, are things that multiply with each other. So we have a factor of 3, and we have a factor of x plus 2. These 2 things are being multiplied together, the 3 and the x plus 2 in parentheses. So factors are things that multiply together, so the factors in this case are the x plus 2 and the 3. So I'm going to erase this so it won't get in your way of your notes. All right, the algebraic expression, 3 times x plus 2 is a product with 2 factors. We can use the distributive property to rewrite the product as the sum of 2 terms. So basically, we're going to apply the distributive property. The distributive property states we're going to take the number on the outside, in this case the 3, and we're going to multiply that 3 by each thing on the inside. So I'm going to distribute that 3, and I'm going to multiply it times the x, and then I'm going to take that 3, and I'm going to multiply it times that positive 2. So that gives me now 3x plus 6. If you'll notice this 3x plus 6, this 3x has a variable, this 6 does not. So these are not like terms, so we cannot combine them. So our answer would be 3x plus 2, and as you see down here, we have 2 terms. The first term is 3x, the second term is the 6. Now you're going to use the phrase, or hear the phrase, distributive property a good bit. So when I say the distributive property, it means you're going to take a number on the outside and multiply it by a number on the inside. Another phrase that you're going to hear me say is to expand a problem. When I say expand a problem, I also mean to use the distributive property. So these 2 things mean the same thing. To expand is also to apply the distributive property. All right, let's take this one. Negative 2 times negative 3y plus 5. We have 2 factors. The negative 2 is a factor because it is being multiplied by the other factor. This entire set of parentheses is the other factor, and they're being multiplied because they're side by side with parentheses. So what we're going to do is we're going to distribute that negative 2 times that negative 3y, and also, as the arrow shows, times that positive 5. So if I distribute this negative 2 times negative 3, a negative times a negative is a positive, so that gives us a positive 6y. Then I'm going to take that negative 2, and I'm going to distribute it with that positive 5. A negative times a positive is a negative, so I'm going to write that as minus 15. So after I multiply using the distributive property, or as I expand it, it gives me 6y minus 15. It has 2 terms in it. We have this term with a y. This 15 or minus 15 does not have a variable with it. So these are not like terms. so we cannot combine them, so that is our simplified answer. All right, what I want you to do is I want you to work through these and give these a shot. So if you will, go ahead and pause it and work these 3 problems, please. All right, hopefully you work these 3 problems. I'm going to do the first one with you. We're going to multiply the a times the 2, then the a times the b. A times 2 gives us 2a. A lot of you may have written it as a2, but get in the habit of writing the number in front of the variable. So we're going to say 2a. And then a times b, we're going to write that as just ab. And some of you may have written it as ba, but the accepted form or the correct way of writing it is alphabetical order, so we're going to say AB. So our answer would be this one right here. All right, the next one, we're going to distribute the 5. 5 times 1 gives you 5. Then we're going to multiply 5 times that minus 4c. A lot of you like to just bring that over, so let's just bring that minus sign over and then do 5 times 4c. 5 times 4 is 20. So what we're going to do is just put 20 and then put the c with it. So our answer is 5 minus 20c. All right, we're going to do the same thing for the third one. We're going to distribute that negative 0.2 or the negative 2/10. The negative 2 times the negative 2/10 times the 7x. 2 times 7 is 14, and if you think about it with the decimal, that means we're going to move the decimal 1 place to the left. So that gives us negative 1.4, and I'm going to put the x with it. And then we're going to multiply the negative 2 times that negative 0.3. So a negative times a negative is a positive. So when we multiply those together, that gives us a positive 0.06, which gives us this first answer right here. All right. This one says, which expression shows a sum or difference equivalent to negative 1/5 times negative 5m plus 10. Now, I'm going to work through this one with you because I want to show you how we work with the fractions, even though we've talked about it before. So we know that we're going to distribute this negative 1/5, and we're going to distribute to each thing in the parentheses. So we're going to distribute that negative 1/5 times the negative 5m. So I'm going to write it like this. Then we're going to distribute that negative 1/5 and multiply that times the positive 10. Now, this is where I just want you to recall some things. We talked about multiplying a fraction times a whole number. You have several options. We can take the negative 1/5 and multiply it times this negative 5 by putting a 1 under it and making it a fraction and multiply straight across. Negative 1 times negative 5 gives you a positive 5. 5 times 1 gives you a positive 5. 5 over 5 equals 1, which is the correct answer. All right, you also have a little shortcut that I showed you. We can take the negative 1/5, multiply it times the negative 5. Remember what I said about multiplying a fraction times a whole number. Take the whole number, multiply it by the top. So 5 times 1 is 5. Then you divide it by the bottom number. So 5 times 1 is 5. Divide it by this 5, and you get 1. And a negative times a negative gives you a positive. So this is a positive 1m. Let's do the same thing to the other side. We have a negative 1/5 times a positive 10. Multiply 10 times the top number. 10 times 1 is 10. Divide it by the bottom number. So we're divided by that 5. 10 times 1 is 10. Divided by 5 gives you a 2. And since we're multiplying a negative times a positive, that gives you a negative 2. So the way I'm going to write this is minus 2. And that's 1m minus 2, so we all know we don't need that that 1. So I'm going to just write this as m minus 2. Both of these represent the same answer, but try to get in the habit of writing it without the variable, without the coefficient in front of it. All right, so what I want you to do is to work these 3 problems and see which one of those 2, maybe 2 of them, maybe 3 of them, maybe 1 of them, may not be any of them, have the same answer as the m minus 2. So if you'll pause the video and work those 3, please. So just in case some of you are wondering, yes, I want you to work these 3. And you'll make sure that you have this right here. That way you have the example that I went over by multiplying a fraction times a whole number.